This is my Precalculus course. Today we're going to review polynomials. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. In my beginning algebra course, we introduced polynomials, but we're going to review and go into some more detail in this curriculum. Polynomials are a huge part of the math curriculum in general, and I've given you a specific definition here, but be aware this definition excludes polynomials with multiple variables. You may see a polynomial that has x's and y's and z's, or a, b, and c's, so on and so forth. Just to simplify things, we're just going to analyze polynomials with one variable, like you see here. It's important to understand that there are some restrictions when defining an expression as a polynomial. The exponents of the variables must be positive, and they must be whole numbers. Now, whole numbers include 0. That's just the way mathematicians define it. So the exponents can be 0, 1, 2, 3, 4, but we can't have fractions as exponents, and we can't have negative numbers. So let's do some practice problems to help us understand which expressions are polynomials and which expressions are not. It says, determine if the expressions below are polynomials. If not, circle the terms that disqualify each expression. So this is not a polynomial, and the reason is this term here. You can't have a variable as an exponent, so we say no, that's not a polynomial. Now for number 2, that is a polynomial. There's nothing that disqualifies that expression. Number 3, the answer is no, that is not a polynomial. And it's because of this term and this term. You can't have a negative exponent at the left, and you can't have a fraction exponent at the right. Number 4 is a polynomial. Number 5 is not a polynomial because we have a square root of a variable. Now you can have square root 2 times x, that's fine, but you can't have the variable in a square root symbol. Remember, square root x means x to the 1/2, and you can't have fraction exponents. So we're going to circle that term there. And number 2 is kind of a trick problem. We see a fraction here, but that's okay. We just can't have fraction exponents. And over here, we don't have an exponent at all, but remember, if there's no exponent, it's assumed to be 1, and that's okay. Remember, our exponents can be whole numbers, which are numbers that include 0 and 1. So yes, that is a polynomial. And I forgot to mention, whatever number is in front of each term in a polynomial, those numbers are called coefficients. That's very important to remember. We've talked about coefficients a lot, but I just want to remind you that these numbers, 4, 9, -1, those are coefficients of each term. Okay, number 7 is a polynomial. There's nothing to disqualify it. Number 8 is not a polynomial because we have this term here. Remember, you can rewrite that as -5x to the -2, because this x squared at the bottom can go up as x to the -2 power. Remember, that's rule number, I believe that's rule number 8 in our exponent rules. So you can't have a negative exponent. It's not allowed. Number 9 is a trick problem. Number 9 actually is a polynomial. You might say, well, wait a second, we can't have a pi. Well, pi is just a constant, so it's okay to have pi as a term. If you had x to the pi power, now that wouldn't be allowed, because pi is not it's not a whole number. Or if you had pi to the x power, that would not be allowed because you can't have a variable in an exponent. Now this right here, you might think, well, what about x to the 0? Well, 0 is a whole number, so that's okay. Also, that just simplifies to 1. X to the 0 power is 1. So 1 is okay, as we saw up here. So that was kind of a trick problem. Now for number 10, it's not a polynomial because of that term there. We have a negative exponent, and it's also a fraction. Now you might say, well, what about this 0.002? That disqualifies that term, right? Well, no, the coefficient can be any number as long as it's a constant. So that's fine. So I'm going to leave those in the screen, and I want you to do number 11. Determine if each of these problems can be classified as a polynomial, or if there's a term that disqualifies it, and circle the term that disqualifies. So try number 11. When you come back, we'll do it together. All right, we're back. The answer is yes, this is a polynomial. Try number 12. When you come back, we'll do it together. All right, we're back. The answer is no, this is not a polynomial because of this term here. That's x to the negative 4 power. And also this term is a negative exponent. So those two terms disqualify that. So if you got that answer, good job. Remember to circle the terms that disqualify the expression. Try number 13. When you come back, we'll do it together. All right, we're back. The answer is no, you can't have a variable and an exponent. And this term here is x to the 1/3 power. Remember our exponent rules. So that cannot be a polynomial. So if you got that right, good job. Try 14. When you come back, we'll do it together. All right, we're back. This is not a polynomial because of that term. We can't have a variable inside a logarithm. So that was kind of a trick problem because we had a logarithm. But if you got that one right, good job. If you didn't, that's okay because that was kind of a trick. We had a logarithm in there. Try number 15, and when you come back, we'll do it together. Here's another trick problem. It doesn't look like it can be a polynomial, but it can because it's okay to have a mixed number as just a constant. And even though these exponents are really large, that's okay. It's still a polynomial. If you got that answer, good job. Try number 16. When you come back, we'll do it together. All right, we're back. The answer is yes, that is a polynomial. We do have a fraction here, but that's okay. The coefficient can be any constant. It can be a fraction, it can be anything. It's just the exponents that can't be fractions or negative numbers. Try number 17. When you come back, we'll do it together. All right, we're back. The answer is yes, that is a polynomial. Again, these are kind of trick problems because we see we have x cubed over 7, but that can be written in the form 1/7 x cubed. So you just have your coefficient here. That's perfectly fine. Some of these problems are kind of tricky, so if you're getting some of these wrong, that's okay. This is just to kind of get you familiar with what is and what is not a polynomial. Try number 18. When you come back, we'll do it together. All right, we're back. The answer is no, because we have a variable in the denominator. That's x to the negative 4 if you bring it up. 500 pi is okay. That's just a constant, and this is fine over here. Try number 19. When you come back, we'll do it together. All right, we're back. The answer is yes, that's a polynomial. Again, this is just 3. X to the 0 power is just 1. So if you got that right, good job. Try one more, number 20. When you come back, we'll do it together. All right, we're back. This is not a polynomial because of that term. And let's go back over and see if we missed any terms that needed to be circled. I don't see any terms. Everything looks right. So if you got those answers, good job. an expression must be in this form to be a polynomial. So remember, not everything is a polynomial. So now we're going to do some review problems that we did in my beginning algebra course. Again, to help us understand how to work with polynomials. So it says simplify each polynomial, write in descending order of powers, and identify the degree. So we're going to do 3 things for each one of these problems. First thing we're going to do is simplify. This term here and this term, they both have x to the 7th on them. So what that means is they're like terms. Remember, you can combine like terms. So 8 plus 3 is 11. So we combined the purple terms into 11x to the 7th. Now, and notice that I started with the highest power. It says write in descending order of powers. So you want to start with the highest power. Negative 2x to the 5th and negative 9x to the 5th, those are like terms because they both have x to the 5th on them. Negative 2 plus negative 9 is negative 11. And 6x, there's nothing really to combine that with, so we can just rewrite it. Any number that doesn't have a like term, you can just rewrite it. And 4 doesn't have anything really to combine it with, so we just rewrite that, and we're done. We did 2 things. Number 1, we simplified the polynomial. We converted from a 1, 2, 3, 4, 5, 6 term polynomial to a 4-term polynomial. And we wrote in descending order of powers. You see these exponents? See how the exponents are going down? 7, 5, 1, 0. This is called a 0 power term because 4 can be written as 4x to the 0. X to the 0 is 1. I know that's kind of confusing, but now there's one more thing we have to do. We have to write the degree of this polynomial. Now it's been a while since we went over this, but degree is simply the highest exponent, or the greatest exponent in the polynomial, which as you can see is this 7 right here. See that 7? The highest exponent is this 7 here. So we can just write d is equal to 7, and make sure you write a comma there to separate your answers. Okay, let's try one more of these. As you can see, these are really not difficult. We don't have to spend a lot of time on this. So we're going to start with the largest power first, and we have 3x to the 4th and 8x to the 4th. We're going to add those and we get 11. So we have 11x to the 4th. I'm going to shade those. And then we have our x squared terms. We have 3 of those. I'm going to use a different color here, here, and here. So negative 5 plus 3 is negative 2. Negative 2 plus negative 4 is negative 6. And we can shade those, just to know that we've already combined those. And then we have 6x and negative 2x and 5x. 6x minus 2x is 4x. 4x plus 5x is 9x. And we have 10 minus 9, which is 1. So there you go. Now the degree is the highest power. That's this this orange number over here, 4. So the degree is 4, the degree of the polynomial. Okay, why don't you go ahead and try number 23, and when you come back, we'll do it together. All right, we're back. So we're going to rewrite this negative x cubed term, and then we're going to combine the x squared terms. Negative 12 plus 3 is negative 9. Negative 9 plus 1 is negative 8. So we can cross those out or shade them, however you want to do it. And then we're going to combine the 6x and the negative 8x. We get negative 2x. And then we're going to combine the 1 and the 2. Don't forget that 2 at the very left. 2 plus 1 is 3. So if you got that answer, good job. Don't forget to write your degree, though. The degree of this polynomial is 3. Where did I get that number? Right there. Remember, the degree of a polynomial is the greatest exponent. So if you got that answer, good job. Go ahead and try 24. When you come back, we'll do it together. All right, we're back. We're going to combine the 3x to the 4th terms. 3 plus 2 is 5. We can shade those. We've already combined those. And negative 5 x squared plus x squared is negative 4x squared. So we can shade those. And 8x minus 3x is 5x. So we can shade those. And then we have that 1 at the right. So if you got that answer, good job. It's always good to go back and double check, make sure we did everything correctly. It looks right. The degree is the greatest exponent, which is 4. And remember, you want to write in descending order of powers. We have 4, 2, 1, 0. Okay, now we're going to add polynomials. When you're adding polynomials, you don't really need parentheses. The whole purpose of these parentheses is to show that you're adding the yellow polynomial with the blue polynomial. But really, you can just get rid of those parentheses. When you're adding polynomials, you don't need parentheses. And we're just going to keep that plus sign in between them. So now it just becomes the same problem we were doing before. So let's write the highest exponent first. And then we have negative 2x squared plus 3x squared is x squared. And I should probably shade these to know which ones that we've combined. And 6x plus 6x is 12x. And negative 8 plus negative 4 is negative 12. Now this problem set does not ask you to write the degree, so you don't have to write the degree. On to number 26. Now you don't have to show this intermediate step in these problems, so we can just combine the x cubed and the 4x cubed to get 5x cubed. And the negative 2x squared doesn't really have anything to combine it with, so we can just rewrite that. And we have 3 and negative 5, which make negative 2. Just adding those together. 3 plus negative 5. Okay, now time for you to try attempt number 27. When you come back, we'll do it together. All right, we're back. We have a x to the 5th power term. There's nothing to combine it with, so we'll just rewrite that. We also have a x to the 4th power term. There's nothing to combine that with, so we'll just rewrite that. And again, you can lightly cross some of these out if you need to. We have a 2x cubed term and a negative 3x cubed term. So 2 minus 3 is negative 1. And it looks like we have an x squared term, but nothing to combine it with, so we'll just rewrite that. And we have a negative 6 term and a negative 1 term. So negative 6 plus negative 1 is negative 7. And that's it. So as you can see, adding polynomials is pretty easy. If you got that answer, good job. Try number 28, and when you come back, we'll do it together. All right, we're back. So we have a 2x cubed term. And by the way, it is better. It doesn't actually tell you to write in descending order of powers, but it's better to write the highest power first. That's just traditional. 5x plus 6x is 11x. And 7 plus 7 is 14. So if you got that answer, excellent. Okay, so now we're going to subtract polynomials. We simplified polynomials, we wrote the degree of polynomials, and we added polynomials together. Now we're going to subtract them. So when you're subtracting polynomials, it's a little bit more complicated. When you're subtracting polynomials, we don't need parentheses on the expression that you're subtracting something from. So we can just get rid of those parentheses. But it's extremely important to understand that we do need parentheses here in the polynomial that we're subtracting. Now there's a number of ways to think about this. Now probably the easiest way to think about this is you're going to just get rid of this subtraction symbol, and then you're going to change all the signs of the terms in this polynomial that you're subtracting. This is a positive 6x cubed, so it becomes a negative 6x cubed. This is a negative 7x squared, so it's going to become a positive 7x squared. That's because you're subtracting all these terms. This is a positive 2x, so it's going to become a negative 2x. And this is a negative 10, so it's going to become a positive 10. So that's one way to think about it. That's probably the easiest way. Another way to think about it is this negative here is just negative 1 times all those terms. So you're just using the distributive property. So you multiply negative 1 into all these terms, and they change sign, and then you just add the resulting polynomial to the first polynomial. So you can do it however you want. But the most important thing to understand is you're subtracting all these terms, which means that all the signs of these terms are going to change. And once that happens, this negative, you can just make it disappear. Now it's important to understand that this negative is not quite the same thing as this negative. This negative applies to all these terms, whereas this negative here only applies to 6x cubed. So that's why we say that this negative kind of disappears, even though it doesn't look like it disappeared. It's still there. Okay, so now it's the same problem that we did before. We're just combining like terms. So 4x cubed minus 6x cubed is negative 2x cubed. And negative 9x squared plus 7x squared is negative 2x squared. Now again, you don't have to cross out like this. It just helps to know which ones that you've already combined. Negative 2x plus negative 2x is negative 4x. And 3 plus 10 is 13. So there you go. All right. Let's try one more of those before you try one on your own. So we're going to get rid of the parentheses on the first polynomial. When you're adding polynomials, you don't need any parentheses really. But when you're subtracting, you need these parentheses. You don't need these parentheses. So we got rid of the parentheses on the first polynomial. Then we're going to make this negative disappear and change all the signs of the terms. This is a positive 8x cubed, so it becomes a negative 8x cubed. This is a positive 2x squared, so it becomes a negative 2x squared, and so on and so forth. Now we have the same problem that we had when we were adding polynomials. We just combine like terms. So it looks like we have a 10x to the fourth term, and 3x cubed and negative 8x cubed make negative 5x cubed. So that's these two terms. And we have a 2x or a negative 2x squared term and a 3x term, and negative 7 plus negative 2 is negative 9. So go ahead and try number 31, and when you come back we'll do it together. Okay, we're back. So we're going to get rid of the parentheses on the first polynomial. We're going to erase this negative here and just change all the signs. So this is a positive 3x to the fourth, so it becomes negative 3x to the fourth. And this is a negative 6x cubed, so it becomes positive 6x cubed. Positive 2x squared becomes negative 2x squared, and so on and so forth. And once you do that, we don't need the parentheses anymore. So at this point, we can combine like terms. So we have the negative 3x to the fourth term, and the x cubed terms, negative 5x cubed plus 6x cubed is 1x cubed. And we have a negative 2x squared term, and actually two of those, so they add up to make negative 4x squared. And 6x plus 3x is 9x. And 3 plus 5 is 8. So if you got that answer, excellent. Go ahead and try number 32, and when you come back, we'll do it together. So we're going to rewrite that polynomial and get rid of the parentheses. And then we're going to make this negative disappear and change the signs of all the terms in this polynomial. So this is a negative x cubed, so it becomes positive 2x cubed, and this is a positive 6x, so it becomes a negative 6x, and this is a negative 9, so it becomes positive 9. Go back over your work, make sure everything looks right. Then we're going to combine like terms. We have a negative 4x cubed and 2x cubed. So that becomes negative 2x cubed. And then we have x plus negative 6x is negative 5x. And then we have 9. And there you go. So if you got that answer, excellent. Okay, so now we're moving on to multiplying polynomials. We added polynomials, we subtracted polynomials, and now we're multiplying. So we're going to start by multiplying a monomial by a trinomial. Mono means 1, tri means 3. We're going to use the distributive property. So we're going to multiply 8x squared by 3x to the fourth, and then we're going to multiply 8x squared by negative 3x, and then we're going to multiply 8x squared by the last term. Remember, that's the distributive property. So we're multiplying 8x squared by each one of these terms. 8x squared times 3x to the fourth. First we do 3 times 8, which is 24. Then we do x squared times x to the fourth. That's x to the sixth. Remember, that's rule number 1 in our exponent properties. If you multiply powers, you add the exponents. Then we're going to multiply 8x squared by negative 3x. 8 times negative 3 is negative 24. X squared times x is x cubed. So here's 1x over here, and here's 2 x's, so we have a total of 3 x's that we're multiplying. Then we're going to multiply 8x squared by 5. 8 times 5 is 40, and there's no x on 5, so we don't increase the exponent value. And let's go on to number 34. So we're going to multiply negative 2x cubed by 2x to the fourth. Negative 2 times 2 is negative 4. Z to the third power times z to the fourth power is z to the seventh. And now we're going to multiply that monomial by negative 8z cubed. Negative 2 times negative 8 is positive 16. Z to the third times z to the third is z to the sixth. We're just adding the exponents. Then we're going to multiply that monomial by 3z squared. Negative 2 times 3 is negative 6. And z to the third times z to the second is z to the fifth. Again, just adding the exponents. 3 plus 2 is 5. Then we're going to multiply that first term by negative 4z. Negative 2 times negative 4 is positive 8. And z to the third times z is z to the fourth. And now we're going to multiply the first term by negative 9. Negative 2 times negative 9 is positive 18. And z to the third times, there are no z's, so it's just going to be z to the third. So let me shrink that a little bit. So I want you to try number 35. And when you come back, we'll do it together. Okay, we're back. So again, we're going to use the distributive property. So multiplying these, 3y to the fourth times y to the third is 3y to the seventh. And multiplying that first term by negative 5y squared, we get negative 15. Y to the sixth, again adding the exponents, 4 plus 2 is 6. And multiplying these terms, we get negative 3 y to the fifth. And then multiplying 7, we get 21 y to the fourth. So if you got that one right, excellent. Okay, try number 36. When you come back, we'll do it together. Okay, we're back. 3 times 3 is 9. X to the 8 times x to the fourth is x to the 12th. So we multiplied these two terms here. And now we're going to multiply these two terms. 3 times negative 2 is negative 6. X to the 8 times x to the third is x to the 11th. And now we're going to multiply that monomial by negative 7. And we get negative 21. X to the 8. And we just have to rectangle that. And we're done. So if you got that answer, good job. Okay, so since we're reviewing multiplication of polynomials, we're going to review just quickly here how to multiply binomials. Now, you don't really need to go over this much because you've seen this quite a few times in my intermediate algebra curriculum. But remember to multiply binomials, and these are called binomials because this has two terms and this has two terms. So we're multiplying the yellow binomial and the green binomial together. The easiest way to do this is to use the acronym FOIL. You multiply the first terms, then you multiply the outside terms, then you multiply the inside terms, then you multiply the last terms. That's what FOIL stands for. Now, some students are taught this box method where you put x here and -2 here and x here and 6 here and so on and so forth, but that's not really practical to write that box out every time you do this, so we're going to use FOIL. So f is first terms, x times x is x squared, and outside, O stands for outside, x times 6 is 6x. Again, I know this is something you've already done a million times, but we're just reviewing this real quickly. Inside terms, -2 times x is -2x. And L stands for last terms. -2 times 6 is -12. Now, it's very important to understand that these happen to be like terms. That's not always going to be the case when you're multiplying binomials, but most of the time that is going to be true. So we're going to combine those like terms. 6x minus 2x is 4x. And there you go. So we're done. So let's try another one of these. 4x times 3x is 12x squared. That's f of FOIL. O of FOIL is 4x times 7 is 28x. I of FOIL, 3 times 3x is 9x. And L of FOIL is 3 times 7, which is 21. Now, again, it's very important to understand that these terms are like terms, so we can combine those. 28x plus 9x is 37x. So we have 12x squared plus 37x plus 21. Go ahead and try 39. Again, I know this is review, but since we're multiplying polynomials, we need to get the hang of multiplying in all the basic cases we're going to see. So try number 39. When you come back, we'll do it together. All right, we're back. X times x is x squared. X times -5 is -5x. -1 times x is -x. -1 times -5 is +5. The inner terms, -5x minus x is -6x. And there you go. So, again, we have FOIL. F-O-I-L. First terms, outside terms, inside terms, last terms. If you got that one right, good job. Let's do just one more of these. Go ahead and try number 40. When you come back, we'll do it together. All right, we're back. X times x is x squared. X times -8 is -8x. 2 times x is 2x. And 2 times -8 is -16. Now the inner terms are like terms, so we can combine -8 and 2x, and we get -6x. And we'll just rewrite the -16. And there you go. So if you got that one right, excellent. Now probably the most complicated type of multiplication you're going to see is this type here. There may be a chance that you'll see something more difficult than that when you go into upper mathematics, but when you have to multiply in the form we did here with binomials, this is usually the most complicated version. But be aware that FOIL does not work when you're multiplying a binomial by a trinomial or anything bigger than a binomial. FOIL only works, the acronym FOIL only works when you're multiplying two binomials. So again, we have a binomial here and we have a binomial here. In this case, we have a binomial, but over here we have a trinomial. So FOIL doesn't work. So how do we do this? Well, the way we're going to do it is we're going to multiply x by all of these terms, and then we're going to multiply 3 by all those terms, and then we're just going to add them up. So every term in this expression is multiplied by every term in this expression. And you could say that the other way also. Every term in this expression is multiplied by every term in this expression. But what is not true is you're not multiplying terms that are in the same expression. You're not multiplying x times 3 or x squared times 4x. Okay, so we're going to start with x. Let's focus on x. So x times all of this stuff. X times x squared is x cubed. X times 4x is 4x squared. X times negative 1 is negative x. All right, we're done with the x. But now we have to move to the 3. Now we're multiplying this 3 by everything in this trinomial. So 3 times x squared is 3x squared. 3 times 4x is 12x. And 3 times negative 1 is negative 3. So now all we have to do is combine like terms. Remember, you have to always simplify if you can. So we have x cubed. We can't combine that with anything. 4x squared plus 3x squared is 7x squared. Negative x plus 12x is 11x. And we rewrite the 3. So let's try another one of these. We're going to start by multiplying x by all these numbers. X times 2x squared is 2x cubed. And x times negative x is negative x squared. X times 6 is 6x. And now we move to negative 5. Negative 5 times 2x squared is negative 10x squared. Negative 5 times negative x is positive 5x. And negative 5 times 6 is negative 30. So then we combine like terms. We have one x cubed term, two negative x squared terms, and 6x plus 5x is 11x. And we just rewrite that negative 30. Okay, why don't you try number 43. Remember, you're going to start by multiplying this number by all these numbers in the trinomial, and then you're going to multiply this number by all the numbers in the trinomial. Try 43. When you come back, we'll do it together. Okay, we're back. X times x squared is x cubed. X times negative 7x is negative 7x squared. X times 5 is 5x. Then we move to 10. Multiply 10 by all those terms in the trinomial. 10 times x squared is 10x squared. 10 times negative 7x is negative 70x. And 10 times 5 is 50. So we have x cubed plus 3x squared. 5x minus 70x is negative 65x. And we'll just rewrite that 50. So if you got that right, good job. Try number 44. When you come back, we'll do it together. Okay, we're back. We're going to start by multiplying 2x by all these numbers. 2x times 3x squared is 6x cubed. 2x times 8x is 16x squared. And 2x times 11 is 22x. Now we're going to move to negative 1. Negative 1 times 3x squared is negative 3x squared. Negative 1 times 8x is negative 8x. And negative 1 times 11 is negative 11. So now we just have to combine like terms. There's only one x cubed term. 16x squared minus 3x squared is 13x squared. 22x minus 8x is 14x. And there's nothing to combine the negative 11 with. So there you go. If you got that answer, excellent. Okay, so we added, subtracted, and multiplied polynomials. Now we're going to divide polynomials. We're going to divide this polynomial by this monomial. Mono means one, poly means many. And when you do that, you simply divide each one of these terms by the blue monomial. So we'll start with these terms. 10 divided by 2 is 5. X to the 6th divided by x to the 2nd is x to the 4th. When you divide powers, you subtract the exponents. That's rule number 2 in our exponent properties. Now we're going to divide these terms. 20 divided by 2 is 10. And x to the 5th divided by x to the 2nd is x to the 3rd. You just subtract the exponents. 5 minus 2 is 3. Negative 16x to the 4th divided by 2x squared is negative 8. Negative 16 divided by 2 is negative 8. X to the 4th divided by x to the 2nd is x squared. 4 minus 2 is 2. Then we're going to divide these terms. 4 divided by 2 is 2. And subtracting the exponents, 3 minus 2 is 1. But you don't have to write a 1. So there you go. As you can see, dividing a polynomial by a monomial is pretty easy, at least for these particular problems. Let's try one more before you try one on your own. So we're going to divide this polynomial by this monomial. We're going to start with these terms. 21 divided by 3 is 7. Subtract the powers. 10 minus 5 is 5. So then we're going to, let me write that a little bigger. Then we're going to divide 9z to the 5th. 9 divided by 3 is 3. And notice that those powers are the same, so if you subtract them, you get 0. But anything raised to the 0 power is just 1. So that becomes 3 times 1, which is just 3. So you can just cancel those z's out completely. They cancel each other out. Go ahead and try number 47, and when you come back, we'll do it together. All right, we're back. We're going to divide each one of these terms. We'll start with these two terms. Negative 36 divided by negative 9 is 4. Subtracting the exponents on the variables, 7 minus 3 is 4. Then we're going to divide these terms. Negative 27 divided by negative 9 is positive 3. Y to the 6th divided by y to the 3rd is y to the 3rd power. Then we're going to divide these terms. 45 divided by negative 9 is negative 5. And y to the 5th divided by y to the 3rd is y to the 2nd. And negative 81 divided by negative 9 is positive 9. And y to the 4th divided by y to the 3rd is y. So if you got that answer, good job. Now for number 48, be aware that this x down here has a power of 1. There is no 1 there, but remember, if there's no exponent, it's assumed to be 1. So go ahead and try 48. When you come back, we'll do it together. Okay, we're back. 25 divided by negative 5 is negative 5. X to the 5th divided by x is x to the 4th. So we're just reducing all these powers by 1. 60 divided by negative 5 is negative 12. X to the 4th divided by x is x cubed. Negative 35 divided by negative 5 is positive 7. X to the 3rd divided by x is x squared. Negative 70 divided by negative 5 is positive 14. And again, just reducing the exponents by 1 unit. 40x divided by negative 5x, that becomes negative 8. And the x's just cancel out. If you subtract the powers, 1 minus 1 is just 0. X to the 0 is just 1. So that becomes 8 times 1, which is just 8. So if you got that answer, excellent. Now notice in all these problems we were dividing by a monomial, meaning an expression with one term. In the next class, we're going to divide by an expression with multiple terms, maybe a binomial, a trinomial. But when we divide by binomials or trinomials or polynomials with 4, 5, 6 terms, we have to use something called long division. Now, we learned arithmetic long division, what I call arithmetic long division, in my arithmetic course. That's when you just divide normal numbers. But when you divide polynomials, you're going to need to use that same long division process. So what I'd like to do is review basic long division. There's a lot of students who may not really need to review this. You know how to do this. But in my curriculum, we haven't done this for quite a while. We learned this in my arithmetic course, but we need to do a little bit of review just in case we forgot some of this. So we're going to divide 7,491 by 3. What you do is you write the divisor, then you draw an L shape, an L that's kind of flipped to the right, and you're going to write your dividend inside. And then you're going to ask, how many times does 3 go into 7? How many times does 3 fit into 7? And the answer is 2 times. Then you're going to multiply these two numbers. 3 times 2 is 6, and write the 6 down here. Then you're going to draw a line, horizontal line. Then you're going to subtract these numbers. 7 minus 6 is 1. So that's one cycle that we have to do with long division. But if you recall, long division consists of many, many cycles. That's why it's called long division. It keeps going and going in some cases. So what we're going to do is we're going to bring down the 4, because we have more numbers here, and then we're going to start that entire process over again. And there's 3 steps to each cycle. We figure out how many times the number goes in, then we multiply these two numbers, then we subtract. 3 steps for every cycle. So now we're going to start those 3 steps again, but instead of figuring out how many times this number goes into these numbers, we're going to figure out how many times this number goes into this number down here. 3 goes in 4 times, so we're going to put our 4 up here. That's step number 1. Then we're going to multiply these two numbers. That's step number 2. Then we're going to subtract these numbers down here. That's step number 3. And there you go. That's cycle number 2. So we always do these same 3 steps. Figure out how many times the number goes in, multiply the two numbers, subtract. Figure out how many times the number goes in, multiply the numbers, subtract. It's always the same 3 steps. So now we have more numbers, so I'm going to bring down the 9. And step number 1 of cycle 3, how many times does 3 go into 29? It goes in 9 times, so I'm going to put my 9 up here. That was step number 1. So now we're going to step number 2. We're going to multiply 3 and 9. 3 times 9 is 27. Then we go to step number 3. We're going to subtract these numbers, and we get 2. Okay, so we have one more number, so we're going to bring that 1 down. And we're going to do this cycle one more time. This is the 4th cycle. How many times does 3 go into 21? It goes in 7 times. So I put the 7 above the 1 up here. Try to line those numbers up as best you can. Then step number 2, 3 times 7 is 21. Our 21 goes down here. Step number 3 is to subtract these numbers. 21 minus 21 is 0. So in this case, our remainder was 0. Our remainder is not always going to be 0, but in this case it was. So what does this mean? It means when you divide these two numbers, 7,491 by 3, you get this number up here. So that's our final answer. I'm going to write that over here. 2,497 is our final answer. So how many times can you fit 3 into 7,491? You can fit it 2,497 times. Another way to think about that is you're taking this number and dividing it into 3 equal parts and asking how big is each part. I know this is a review for most students, but we're going to need to use this long division algorithm when dividing polynomials. So let's go to example 2. Again, we're going to write the dividend and put a L over it and the divisor. And we're going to ask how many times does 8 go into 2? Now in this example, 8 doesn't go into the first number. So we're then going to ask how many times does 8 go into 21? And it goes 2 times. That's step number 1 of cycle 1. Step number 2, multiply 8 and 2, and we get 16. That's step number 2. Step number 3, subtract 21 and 16, and we get 5. Now we start the cycle over again, but first we have to bring down 3. Don't forget that. How many times does 8 go into 53? That's step 1 of cycle 2. It goes in 6 times. I'm going to put the 6 here. Step number 2, multiply 8 and 6, and we get 48. Step number 3, we're going to subtract these numbers. 53 minus 48 is 5. And then we have one more number to bring down. So we're going to bring down that 5. And we get 55 there. And now we're going to cycle 3. Step 1, how many times does 8 go into 55? It goes in 6 times. That's step 1 of cycle 3. Then we're going to go to step 2, multiply 8 and 6, we get 48. Then step 3, subtract 55, or subtract 48 from 55, and we get 7. Now notice that there are no more numbers over here to bring down. So what that means is we're done. We say that the answer is 266, remainder 7. All right. Now in my arithmetic course, we always wrote remainder 7, but now that we're in upper mathematics, we're not going to do that. That's not really the best way to write the answer. This answer should be written as 266 plus 7 over 8. So you always take the remainder and write it in the numerator of a fraction that you're adding to the final quotient here, and you take the denominator, or excuse me, the divisor, and write it as the denominator. So that's where I got that number. That's always going to be the case. You always take the divisor and write it there. The remainder came from there, and this number came from here. Now just be aware that you can write it as 266 and 7/8. That's a mixed number. You can write it that way if you want, but I prefer if you wrote it in this form because we're going to need that form in the next class. So go ahead and try example 3, and when you come back, we'll do it together. Okay, we're back. So we're going to write the divisor, and then an L turned over, and then the dividend. Some students say, well, wait a second, you forgot to write the comma. Well, sometimes the comma is omitted when you're writing a number that's in the thousands. When you go to 5-digit numbers or 6-digit numbers, you always have to write the comma, but in this case it's sometimes omitted. So now we ask, how many times does 4 go into 5? Well, obviously it goes in one time. That's step number 1. Now we multiply 4 and 5, 4 and 1. 4 times 1 is 4. Then we subtract. 5 minus 4 is 1. So that is cycle 1. Now we have more numbers, so we bring down the 5. We have more numbers here. Now we start the entire cycle over again. How many times is 4 going to 15? 3 times. That's step number 1. Step number 2, we multiply 4 and 3 to get 12. Step number 3, we subtract 12 from 15. And we have more numbers, so we'll bring down 7. And we start the entire process over again. Step number 1, how many times is 4 going to 37? It goes in 9 times. Step number 2, 4 times 9 is 36. Step number 3, subtract these numbers down here. 37 minus 36 is 1. And now we ask, do we have more numbers to bring down? And we do. So I'm going to bring down that 6. And now we start the entire cycle over again. How many times is 4 going to 16? That's step number 1. And it goes in 4 times. Step number 2, multiply those two numbers. 4 times 4 is 16. Step number 3, subtract these numbers down here. 16 minus 16 is 0. So the remainder on that problem was 0. So if you got that answer, good job. Let's write the final answer with a comma. When you write a 4-digit number formally, it's got to have a comma there. So again, if you got that right, good job. Try example 4. When you come back, we'll do it together. All right, we're back. So we're going to write our divisor and then a little L shape and the dividend. How many times does 5 go into 1? It doesn't go into 1. So you ask, how many times does 5 go into 12? It goes in twice. Very important that you write the number on top of the last digit of the number you're dividing into. That's going to become important when you're dividing decimals. Not so important for this class. Step 2, we're going to multiply 5 and 2. 5 times 2 is 10. Step number 3, we're going to subtract these numbers. 12 minus 10 is 2. Then we have more numbers to bring down. So I'm going to bring down the 8. And we'll start the entire process over again. How many times does 5 go into 28? It goes 5 times. That's step number 1. Step number 2, multiply 5 and 5. You get 25. Step number 3, subtract these numbers. 28 minus 25 is 3. And we have more numbers to bring down, so I'm going to bring down that 7. And we'll start the entire process over again. How many times does 5 go into 37? That's step 1. It goes in 7 times. Step 2, multiply 5 and 7, you get 35. And step 3, subtract. 37 minus 35 is 2. So notice we don't have any more numbers over here. So we have a remainder. So in my arithmetic course, we would write 257 R2, meaning remainder 2. But in this class, we're going to write 257, and we got that number from here. Then we're going to add 2, we got that number from here, over 5, and we got the 5 from up here. That's the divisor. So if you got that answer, good job. Now again, you can write that as 257 and 2/5 as a mixed number. That's fine, but I'd prefer that you write it like we did down here, because this is going to lead us to what we're going to study in the next class. So that was the class today. Again, just reviewing polynomials and a little long division, arithmetic long division. Take screenshots. Here's screenshot number 1 to help you with your homework or to study for tests. Here's screenshot number 2, or you can take pictures with your phone. And screenshot number 3, but don't go before you get your homework. Remember, the homework is the most important part of any math course. Let's take a look at the homework. Go ahead and get a screenshot or a picture with your phone of this first page and the second page. But don't go before you get the answers for the homework. Here are the answers. And be sure to do these last problems. I know this is just basic arithmetic, but even if you are confident that you know how to do the long division, go ahead and just do these problems for practice, because we're going to need those in the next class. So get that homework done completely, correctly, neatly, and keep it in order in your binder. Remember, if you don't do the homework, it's a 100% guarantee you're going to learn nothing in the entire class. So get that homework done, and I'll look forward to seeing you in the next class.